Hi, my name is Ajay Raj, and this is my TP for CS 15112, the fall lecture. So my game is called Drawmania, and this is our cover screen. It's essentially like a retro style, essentially maze runner, but it also has like a really cool drawing component to it. Really active and sort of like invigorating enemies as well, and just a lot of opposition within the actual maze itself. You're trying to find yourself, locate the actual like false portal after killing a certain number of enemies to actually escape the maze. So here are the instructions. So you have to kill 20 plus enemies and find the portal, which is the false wall. You should avoid enemies and moving walls, they decrease your HP. You have to draw shapes to defeat enemies on them, and also the lower the points for a win, the better, essentially. So I'll also keep a ranking of the total scores, so you can just constantly keep comparing your highest scores. So now we've entered the game itself. As you can see, it's really fast paced here. So essentially we have our enemies, which are essentially the raycasted images. Everything is raycasted, the entire maze, as you can see. The walls themselves are actually 3D. I have bounding movement as I move through the entirety of the maze. And yeah, essentially it's a maze that was random generated. So I used the DFS depth first search generation algorithm. So it randomly generates a 10 by 10 maze, but the user can essentially set any configuration that they want, and it'll always have a valid ending to it, essentially. There's no blocked off paths, so on and so forth. And I essentially random generate where the false portal will be. That's always going to be on the actual maze itself. As you can see here, these are the enemies themselves. So once they enter a certain hit radius, they will begin to inflict damage on the individual, and your HP, as you can see in the top left corner, starts to go down. So essentially you want to avoid that. Once you hit 0, the game will essentially end. So as the game goes on, after every 15 seconds, you'll have increasing waves. You'll feel the intensity of higher pace. You'll essentially have more enemies generating as well. And essentially their hit radius gets essentially farther. So they can start hitting you from farther away as time goes on. So that radius starts to increase, essentially. And so as you can see here, essentially like there's this oscillating movement as though the enemies are inflicting damage upon you. This is done using a pathfinding algorithm, which is sort of like my own modified version of A star. Essentially, so it finds the least path, essentially least path of resistance, or the quickest path to me within the actual maze itself. The enemies never go through the walls, and as you can see here, these are the actual oscillating walls themselves. I randomly generate them within the maze itself, and they oscillate between the largest gap corridors that they're essentially existing within, and you also lose damage once you go through them. As you can see, the flickers in the backgrounds that are essentially going off. And now comes like the main part here. So as you can see here, we're really low on HP. Now we need to start to essentially like pick up the slack here. So we can start to draw actual patterns on our enemies themselves. I use a form of dynamic time warping, which essentially calculates a least epsilon to essentially what I use as like a basis figure for every single shape that I'm going to cycle through and request the user draw. And once they draw an accurate figure within a certain margin of error, which I set to be about 20%, it'll actually kill the enemies and all enemies that are bounding within the box or within that shape. So a certain part of the actual like drawing has to be on the enemy to kill them. You can't just draw anywhere, and you can't just draw any shape that you want. As you can see here, in the top right, it says it's not a valid square, essentially. So the dynamic time warping is essentially foolproof here. So as we can go through, as you're walking through, you want to kill at least 20 enemies to actually even be able to defeat the maze. And you want to do this quickly because, as you can see, the pace of the enemies is essentially starting to pick up, and they're starting to group together more. So it's going to be more like a wave attack on you. And as you can see, like taking more damage as well as you're going through. So now, like after that game is just as a demo, I skipped forward to see another game where we had 22 kills here already, and I found the false wall itself, and it stored all the prior scores of past runs, as you can see on the screen. That'll keep doing that. I used object-oriented programming to actually do that. So I essentially had my own static, essentially list, it's my own static sort of variable, and that kept track of all prior runs, and it ranks. Essentially, you want the lowest score, almost like in golfing. You want the lowest score, meaning like the lowest time actually spent. So here we actually died. As you can see here, our score was 16. That's just my own calibrated score, and obviously no top scores when you actually lose the game, because that we're not going to actually rank any of those scores as part of the trial run. So yeah, as you can see here, like this is the essentially the full encompassing aspect of Drawmania overall. Essentially, like major features was the actual raycasting with the DDA algorithm, the depth first search for the random maze generation itself. Actually being able to chop up the images and raycast them on a 3D outlay with a 2D graphics engine. On top of that, I also utilized pathfinding and dynamic time warping to detect the actual patterns as well. and just a lot of randomized elements just to make it cool and interesting.